Those of you familiar with a lot of my much older videos, probably somewhat familiar with this mess. This is the 2011 version of my solar farm control board. Although a bunch of stuff has been added and modified and what have you, because after 2014 lightning strike I had to replace the Sun Forest inverter, which got sorta killed, but it still sorta works me, with this 600 watt Power Bright. Also pure sine inverter. Also added those two PWM charge controllers that I've had for about 7 years now. Got those really on into my experiments with off-grid stuff. Just running a couple 12 volt arrays. Of course I have these two BZ products. MkIII PowerPoint charge controllers that I've featured in various videos in the past. And well, this whole mess is getting not so much decommissioned, but very heavily modified and changed in scope and what have you, will improve a lot of the electrical work, because this was pretty much just a development system. That's why all the wiring's exposed. Getting risk of blah blah. Not so much electrocution unless you do something really dumb, because there's exposed 12 volts on those bus bars, but yeah, it was basically an experiment, see what worked, what doesn't. Long story short, off because of all the storms, but if you remember some of my videos, or if you don't, you're new to my stuff, or just haven't seen the particular video, there used to be 3 batteries here, and then there's 3 more behind that stack of whiteboards. There still are 3 batteries, but one of them is disconnected because it died, but not particularly violently. The battery that used to be where that mousetrap is now, hauled off and shorted 1 or 2 cells last July during some stress testing, and well, needless I got it out because wiring was getting really hot. Of course, the crappy fuse that I had didn't blow. Needless to say, don't get cheap fuses. The battery was really hot, especially on one end. Smelled of brimstone, so yeah, that, and it was making pronounced bubbling noises, so of course immediately took it out the door. And so all this stuff is getting, well, some of it, like the Power Bright's going to be retained. It's just a light running inverter. I'm going to put in a prepper battery box down here, a pair, or possibly 4, but more likely a pair of decent quality golf cart batteries just for running some lights. That Harbor Freight inverter is going to be pulled from service. I'm going to put a pair of jumper cable clip leads on it and turn that into a portable tool running inverter off of cars or in some of the outbuildings. Probably repurpose that load center for some stuff. Part out that. Battery charge will be returned to regular service, as will be the isolation transformer. Also need to clean up all the very schmoo that's accumulated over the past 4.5 years. Because I built this in October 2011 and it's June of 2016 now, so there's about almost half a decade of schmoo gradually accumulating. And in the place of this mess, with this, it's a much bigger, much higher capacity solar farm, which is a more or less a semi-permanent thing for emergency power and what have you, now that we know what works and what doesn't. Got a pair of Midnight Classic 200 SL charge controllers. This one's got 1,560 watts of PV modules on it. This one's got 780 watts. Although right now I've been typically getting a peak of about 1,100 watts out of this guy, and about 600 watts out of this guy during full sun, but the array tilts are wrong, and also there's some losses in the cable because since the photovoltaic array positions aren't finalized yet, each one has a full reel of cable on it, so that is going to reduce losses somewhat once I get everything trimmed to fit, and plus also have a whole bunch of direct burial cable for spare purposes at that point. But yeah, also have disconnect switches, which are dual duty in addition to the regular. De-energize this side of the cable so that I can safely work in the charge controller, or replace the charge controller, or do tests without risk of electrocution, because each of these arrays peaks at about 150, 160 volts open circuit, and maximum power potentials in the neighborhood of about 110 volts to 115 volts. These are also lightning disconnects, which is why these are both down. This basically reduces the likelihood of a close lightning strike getting through to and frying these charge controllers, although this one doesn't have a lightning protector on the PV array side yet. This one does, although this is an MnSPD 300, which is a 300 volt nominal DC version. I'm probably going to, well, I'm getting a MnSPD 115 for this one. I'm probably going to replace this, but retain this in the off chance that I can get some 380 volt microgrid solar equipment. Although, given how stupid expensive it is at that point, there's basically kind of wishful thinking, at least for a couple of years, until I can develop some of my own stuff, because it is one of my ongoing projects, albeit one that's kind of comatose because I've got other things at the moment. But anyways, basically it's something to reduce the likelihood of lightning strikes, gronking stuff, and ideally this will catch it, dump it to ground, and I've also got some additional lightning protection stuff that I'm going to be putting in place, as well as for EMP and what have you. But yeah, it's complicated stuff. But anyways, on the inverter side of things, I have this Outback VFX 3524M 3.5 kVA inverters as the main inverter, which goes to this whole load center mess of thing. And I have this Kotech 1.5 kVA for running other stuff. Just have a 800 volt ampere isolation transformer just to cut down on electrical noise. And also, this thing is acoustically quite noisy because of the squealing of its power supply. Although this is a Samlex made inverter, so this is ordinarily something that retails for $400 to $500. I paid less than $200 from MkIII Jones. Actually, it was $199 because this was removed from new equipment. Although it looks like it was never actually installed in anything, because there weren't any marring of the surface finish in the screw indent. So it was just one little ding on the front cover, one or two other little dings, and that was it. Basically all it means is that it was taken out of the factory that was integrating this into whatever it was going to be integrated into, and then it got either kept in its original bubble bag or put in a fresh one, and then, you know, sent to me in a MkIII Jones box. So what do you do? Have some other stuff like a ground fault interrupter here for a receptacle over there, and this, which is for another outside receptacle that's on this ground fault breaker, although I'll probably swap that over just so that they'll line up if I can get one of these for not stupid expensive, because ordinarily these are $50-something a piece from Home Depot. Even more expensive than the arc fault breakers, which are a little less than $38, but $37 and change. That one just protects that, which is something that I just have for certain circumstances. I'm probably going to be either replacing one of these with an arc fault at some point, or having at least definitely having a couple of spares, since there's electronics in there, and they'd be connected to somewhat long cables. There's a risk of them getting fried in an EMP or something. But yeah, also have a switch down here for turning the main inverter on and off. Light switches, this window for running extension cords in and out of the building without having to chop holes in walls. As well as a screen to keep bugs out. 24 volt interior lights. These are DC rated switches, that's the rather loud click. And 120 volts there, which doesn't do anything because the main inverter isn't on. I'm also going to be putting in a transfer switch at some point if I can get one for cheap. Also have both 24 volt and 120 volt lights, as you've seen. Also have this surge protection receptacle, which also serves as an idiot light to say that the main bus is live, as well as two convenient receptacles. And it also has a warning in it to say that its internal surge capability, or its internal surge protection capability, has been compromised, at least in theory. And there's a screw under that sticker that you turn to shut that up, just so that the alarm doesn't drive you nuts in the interim period between the failure of this being detected and this thing getting replaced. Also have both 24 volt and 120 volt lights. These are just some really cheap 2 for $4. Well, $4 and change, $4.88 or something. Philips LED lamps that I just have as trial specimens, and some 24 volt incandescent lamps. For for something that runs directly off the battery with no inverter. And this entire building is wired with flexible metallic conduit, not armored cable. Makes it quite easy, but as long as you don't install the FMC first. You cut each piece to fit, thread the wires, terminate the ends, then install it. Otherwise, because of the ridges that are inside this stuff, pulling wire through this stuff is an absolute nightmare if they're all curved and in their final position like this. So yeah. And a pair of quite big batteries, 1,279 ampere hours at 12 volts at the 20-hour rate to 80%, because these are made by a forklift battery manufacturer. They're just modified with flag terminals instead of hard cast lead ones. And just to make it so that you can easily pull out each individual jar, because those are only about 130 something pounds a piece, plus another, I think, 140 pounds for the tank, because there's 2 tanks, one for each battery. But overall, the entire thing weighs 1,940 pounds. Yeah, usable capacity is about 33 kilowatt hours, or 32 to 33 kilowatt hours. Which just makes comparing these confusing, but just using the factory numbers makes them look worse than they actually are, which still isn't bad. That, 875 ampere hours to 80% at the 6-hour rate, quite good. But yeah, and also these are quite expensive. These were about $1,900 something per battery. You're going to hear a bunch of stuff about the Tesla Powerwall, but the problem is that that's 350 volts DC to 450 volts DC, and you can't just go and buy one, even though they're quote-unquote $3,000. Once you do the whole song and dance kabuki theater with having to arrange with various installers and middlemen and what have you, your installed cost is going to be no less than $7,000, because that's the smallest I've seen so far in my research. There's a bug flying around the light. But also, that's only 7 kilowatt hours, keep in mind again, over 32 kilowatt hours for this, and you're limited to a maximum about 2 kilowatts instantaneous charging or discharging, whereas this thing could easily handle more than double that, which not on a really regular basis, but certainly charges at over 1,600 watts in decent sun. And I've put loads of over a kilowatt on it so far, and I've got other testing stuff planned. And also, one other thing just to note is it's a 30 volt lamp that I have for use in the 24 volt lights during the day. And I have 24 volt lamps in it now because it's at night and the system isn't charging. But that's just one thing you have to take note of. So having multi-potential lamps or some stuff like these Focus LEDs, these are a couple dollars each, or not a couple, these are about $12 each from Alta Energy Store, and these are good from 11 volts to 30 volts, so these are 12 volt, 24 volt dual capable, or dual potential capable, which is quite useful because I have my dying, presently installed 12 volt system, the 12 volt system I'm going to replace it with, and I have another 12 volt system that I'm going to be installing for running some emergency radios as a completely independent thing, but yeah. And also, because of the risk of explosion associated with 24 volt lamps like this, because if you put these on 120 volts, they will go bang quite violently, or same with 240 volts. Especially if you're in any kind of a circumstance where you have people who are going to mix these things up, what I'd recommend doing is getting something like 28 volt automotive lamps or 24 volt automotive lamps, and having fixtures that only take those so that you have physically incompatible bases, and of course keeping medium screw for your mains lights, well, medium screw or medium dual contact bayonet, depending on what part of the world you're in, because places like the British Isles and former bits of the former British Empire, medium dual contact is quite common, whereas, on this side of the pond it's virtually unheard of aside from low pressure sodium, which is something that's nowhere near as frequently used as it should be, but whatever, this video is long enough. But yeah, now you know why I haven't been doing anything recently. Well, one of the reasons.